Okay, sit down. You as well. Hurry up. Okay, so quick introduction first. My name is Viktor. I work for a company called CloudBees. We are a company behind Enterprise Jenkins and big part of open source, of course. I'm one of the Docker captains. That's a group of, let's say, recognized contributors to Docker. So I'm very close to both Jenkins and Docker and a few other things. And a couple of books that you should buy immediately while I'm speaking. That would make your life much better. That's the only takeaway from this. Buy my books. Okay, so let's start with Agile, right? Everybody's Agile here. Nobody works for waterfall anymore, right? No hands? Okay. No, I thought that kind of Eastern Europe. I don't know. You never know, right? So some 10, 15 years ago, nobody knows when anymore, Agile came in, changed everything, changed how we work, changed how we do development, how do we do testing, and many other things, right? It was great. And it really, really changed the way how we approach software development. The problem is that it failed to change as a movement. It doesn't mean that it applies to every company, but it really failed to change the rest of the process. What comes after development and testing, right? So you ended up with those fancy teams that have daily stand-ups every day and all those things, and then there is still operation department somewhere in a basement waiting for you to open a Jira ticket to tell them to deploy to production, right? Or to be called during the weekend or something like that. So it's quite normal, simply because the problems that Agile was trying to solve when it emerged are quite different than the problems we have today, because today we are talking about real scale, about what we do. We're talking about resiliency. We're talking about uptime that should have 6 nines after comma and all those things, right? So industry requires certain change again, and it will require again afterwards and all those things. And we got DevOps. DevOps is in a way evolution of what Agile started. At least that's how I see it. It kind of tries to embrace the whole process and try to see a bigger picture than Agile was and did actually succeed to see. So the official, it's not official, but kind of description of what DevOps is. Everybody you know what DevOps is. Probably you have DevOps department. If you do, then you're not DevOps, but that's a separate discussion. It's a cross-disciplinary community of practice dedicated to the study of building, evolving, and operating rapidly changing resilient systems at scale. You will not remember this, which is normal. But basically what it tries to actually deal is how to deploy, not how to deploy, how to develop and move throughout the whole life cycle something, a service, or a lot of services, in a really resilient and a big system, right? Talking about tens or hundreds or thousands of servers. Now, when DevOps emerged, it was, I don't know, 5 years ago, maybe something like that. It was really made a huge impact, and especially similarly, simply way like Agile, you have Scrum and you have, let's say, XP. DevOps also attacks two fronts: cultural and technological change that we need to do. But we're not going to talk about culture today. I'm going to focus mostly on technology that you need to adopt if you want to go there, right? Now, with DevOps, when it emerged, it united all those separate teams, right? Development, testing, Agile, those things, operations, monitoring, and all those things. But it really failed to, when it emerged, first couple of years, to change the processes, tools, and architecture, right? It was focused mostly on how can we automate what we have today, right? So you have your application written in, I'm not going to speak swear words, use swear words, so written whatever it is that is running, and then how can we facilitate that application to go to production faster and more easier and automated and all those things, right? What we are seeing today, not today, maybe last couple of years, that we're moving from that concept. We're not automating anymore. We're trying to re-architecture our applications from scratch, because they're not really work. They cannot cope with what we're trying to do today. So it's really changing the processes, tools, architecture, and everything. And the final outcome, what we're trying to do today, or these days, is to enable something that is continuous deployment and self-healing, right? So every commit should go to production. Everybody knows that already. That's not news. And when that goes to production, it should work, right? If you have increase in traffic, it should auto scale. If you have decrease in the traffic, descale. If it goes down, it should go back up, and all those things, right? You're supposed to go to vacation and let machines do what they do best, right? So, in order to set up all that process, in order to do all those things, you need to adopt certain tools, at least types of tools, right? Configuration management and provisioning, everybody's doing that. Probably somebody here is using Chef or Puppet or Ansible. Maybe somebody is unfortunate to use CF Engine. But in one way or another, that is a must. Immutable deployments, that's a bit newer, right? That means that there is no change servers. Think of immutable deployments as if you're not allowed to SSH into your cluster anymore, right? You're not allowed to change anything. Things needs to be immutable, unchangeable. That's the only way we can actually guarantee that it's the same across the whole process. I'm going to get there afterwards. Service discovery is a must. Proxies needs to be dynamic. There cannot be downtime, because if you're deploying multiple times a day, you cannot have that downtime saying, I'm going to stop my application and put a new release on its place. That's simply not feasible anymore. Cluster management, self-healing, centralized monitoring, logging, and all those things. I'm going to go quickly into each of those, so don't worry if you didn't remember. So everything needs to be automated, and everything needs to be without human intervention. Now, this is not really 100% true that you have no human intervention, but that is really the goal that we're striving. And it's feasible when you think about it. You just need to translate those commands that you have in Word documents into scripts, and there you go, right? So machines take over. Let's speak first about configuration management, right? One of the elements of the toolkit of what you should adopt if you want to become DevOps certified. Manual configuration is not feasible anymore, right? Do you SSH into your machines? Do you do something inside of them? If you do, then you're really living in 1999, approximately, 2000 maybe, right? Are you laughing out of self-pity or? Okay. So manual configuration management is really not an option anymore. And there is no real excuse to do it manually, because we really have tools. We're already talking about third generation of those tools. It's not, you're not even early adopter anymore if you start using them. So that's discarded, right? SSH, again, why would you have SSH? Right? Why would you SSH into servers? Except to fix whatever mess you made previously when you SSH'd before, right? That's the only reason why you should have SSH into your servers. Operators are usually a bottleneck. At least companies that I worked for, it's usually, okay, we are all doing this development testing, and then we open Jira ticket and give it to operations, and then they tell us you'll get a server in 3 months, right? That's a bottleneck, and that needs to go away. And when that goes away, where you want to go is self-service, meaning that every single developer should be able to deploy. And if you are an operator, then you should create a service for that developer that he should use, not do the job for him. And finally, self-healing, and everything needs to be automated. Now, that's all self-evident. Maybe self-healing is not self-evident, but it's really not big news. What is big news is that you need to be proactive. You need to approach, similarly like when development departments, developers adopted test-driven development, meaning that we're going to be proactive in a way how we define our tests, and how do we define our requirements. The same thing means for operations, and that's pretty much in line with creating a service for your teams, not doing the job for them. So the tools, right? Anybody using CF Engine? Anybody still so unfortunate? No. Okay, that's good. You don't even know what it is, right? Am I guessing right? Yeah? It's basically father of all configuration management. Then we got Puppet and Chef. Everybody jumped into Puppet and Chef. And finally we got Ansible. Are you using any of those? Really? Is this? Don't. Don't. That was a trick question, right? Simply the problem with all those tools is that they were, and I used a lot of them a lot, so I'm talking, it's a sad story, but the problem is that they're all designed to work with physical servers. They're all designed with static servers. They are not really capable of coping with dynamic clusters like where we are going today. And they will slowly go away. Ansible probably will not slowly go away because Red Hat is selling it like crazy, but sooner or later it will. What we're talking about today, I mean, this is just one example of the tools. There are quite a few others. Is something like a combination of Packer and Terraform. You're using Packer, Terraform? Okay. So the idea behind them is that, like at least in case of those two tools, with Packer you create an image. And that image is unchangeable. Nobody can change it, and we know what's inside, right? And when you want to create your cluster, you just create as many VMs as you want from that image. You want to change something in your cluster, you create a new image, you remove your old VMs, put new VM in its place. And Terraform is really good because it puts cloud as a first-class citizen, meaning that it really understands that everything is dynamic. You will never specify an IP. You will never specify anything in advance. You will just tell him, okay, I need a lot of something. So once you adopt those, and the reason for adoption of those is the time frame changed. What was, before, if you manage it in a day, then you will be working in an organization that is really, really passionate and does things well. Now a day is really too much. Scope changed, clusters changed, right? Everybody's in cloud one way or another, or at least you're planning to go to cloud. Maybe you're planning actually to create private cloud, and you're still not aware that you're going to fail in doing that, and then afterwards you're going to go to public. But sooner or later everybody goes to cloud, right? Or tries to make their own cloud, and fails, as I say. And once you do that, you will realize that the way how you were doing before with the VMware and all those things, it simply does not cut anymore. But what is most important, it needs to be repeatable, automated, and very, very fast. By fast, I mean some of you might come Wednesday to a workshop. By fast, I mean if you need a cluster, 10 minutes should be the maximum to create a whole cluster. If it's less than that, then actually you're wasting your money. It's not you're wasting money, you're wasting time of people that depend on you, right? So once you figure that, so with all those tools, even if you're using Ansible Chef, you're managing your cluster, you're managing how that works, how much VMs you need, how they're provisioned, and all those things, right? But you're not using it for deploying applications. I mean, many people do use Ansible for deploying application, but again, that's another misunderstanding how it should be done. So once you have everything set up and you can create a cluster as fast as you want, we need to think how to deploy our applications, right? If you deploy it immutable, like most of you probably still do, immutable deployments. By immutable deployments, I mean, I don't know, if you're a Java developer, for example, you go there, replace var with another, fiddle a bit with configuration and say, here you go, right, update my application. And then afterwards you complain, why is it different than in my testing environment, right? So, but the bigger problem with immutable deployments is infrastructure, right? Because if your deployments are mutable, that means that your servers you need to manage all the JDKs, Go compiler, Node.js, and all those things, multiply with as many versions as you need, right? Which usually results in companies saying we're going to standardize, right? We're going to all develop in Java 6 until one day we move to what is today, 8? Probably. Anyway. Second is unreliable testing, meaning that at least those that I work with, if there is a single change between how you deploy to testing and how you deploy to production, that's not reliable, right? You did not test what you're putting to production. And the only way to test what you're putting to production is to be exactly the same. And by exactly the same, I mean from your laptops, those of you who have it open, all the way until production. So how do we do that? We do that with immutable deployments. Immutable deployments Now, if you're thinking already about containers, that's not necessarily a container. It can be VM as well. You can create and bake a new VM with every deployment. That's not really a big deal, except that it's slow. So what we get with that is reliability, much higher. Works everywhere the same, meaning that your laptop, your testing environment, integration environment, production, everywhere is exactly the same. The only real problem is why not everybody is doing immutable deployments if they're so cool, right? The problem is really that until 3-4 years ago, your real option are VMs, which are extremely slow, consume too much resources, and all those things. So then you can say that if VMs are not the option, why don't we use containers? And because containers are already around for, what, like 15 years, who is using it for approximately that time? The problem is that it was very, 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 very complicated to create your own containers, again, until Docker appeared, which is, what, like 4 years, something like that. So with Docker, we get immutability, we get isolation, meaning that every single application is isolated from the rest, at least on process level. It's extremely, extremely fast, lightweight, meaning that usually on a typical server, if you would package an application in a VM, you could approximately have 2 to 3 times more applications, more of those same applications packaged in containers than VMs, just for the difference in the resource usage. I mean, that really depends from case to case, but at least approximately 2 times. They're self-sufficient and no infrastructure. And now we are now getting back that if everything is a container, that means that almost nothing is infrastructure, right? Almost nothing needs to be installed on a server, and then we're going back to the story of before, CF Engine, Puppet, Chef disappearing simply because there is nothing for them to do except install Docker Engine, right? And few very, very other things. So Docker. Still, with Docker we package applications, right? With Docker we don't really deploy them to our production environment. We don't deploy them to a cluster because we need something else for that. Docker is not designed for that as it is. And the reason why it's not designed, because you don't really run individual replicas of something, you run a whole stack of something. So what do we use? Cluster orchestration. And before I jump into how we orchestrate clusters today, or some of the ways, is I need to mention how we treat our servers, right? Do you give names to your servers? Do you have a server called Mordor, or I don't know, Garfield, or something like that, right? That's horrible. That means that you have emotional attachment with it. And the problem with emotional attachment is if I kill that something you're emotionally attached to, then you will be very, very sad and depressed. So that's really a difference, is that when you treat them like pets, when you give them names and static IPs and all those things, you think that your objective is to keep them up and running all the times, right? And that's very time consuming. But where we are going today, I think, is that treat them as cattle, meaning that I don't really care. If I need 10 more, I'm going to create 10 more. If one of them, if there is something wrong with one of my servers, you don't fix it. You kill it. You destroy. Go there, I don't know, if you're on Amazon, just destroy it, right? Because you know that you can create, it's much easier to create new ones than to fix what you already have. I already mentioned that SSH should be legal, that should be in Constitution. I mean, because when you think about SSHing, for example, and I'm sure that even if you don't raise your hand, you are SSHing into your servers, right? The thing, imagine if you would be working in something big, let's say Netflix, and somebody says, I have a problem, and you start SSHing from 1 until 10,000 servers that you have over there. I mean, you would spend a lifetime. Simply, it's unscalable. Dynamic, elastic, meaning that, you know, all those things that we have with cloud. Automated, self-healing. Self-healing is a special subject. You need to come to the workshop Wednesday. So what do we use today, right? We use Mesos. Do you know what Mesos is? Mesos Marathon? Do you speak English? No. Okay. Mesos is one of the first tools that appeared in the market. We use it in CloudWiz. There's the guy. He knows it. Probably. Maybe not. I don't know. That that paved the way. Now, if you don't know what it is, then good for you, because you should already jump to Kubernetes or Docker Swarm, either of those two. But the point with all those things is that they take away control from you. When you deploy stuff, you don't decide anymore, oh, I want to deploy here. Oh, I want to do this. You just tell them desire. I want this service to be up and running. And I want to have 57 replicas, and I want each of them to use 5 CPUs. Where it will be deployed, you don't know. Will it run? Probably. So, no service and application dependencies means that each of our applications is just running somewhere inside of container, and it's a cluster, meaning that you stop thinking that you don't care how many servers you have. What you do care is how much CPU you have, and how much memory. So when your mental model changes and start thinking that, oh, I don't have 57 servers, I have 178 CPU, then you're on the right track to use those tools. It's almost instant. It should not take more than a second or two to deploy something, unless actually you have many replicas. Scale, descale effortlessly, meaning that all those tools can provide scaling for you out of the box. That's what they do. And software-defined network, that's an interesting part, is once you adopt schedulers, and they're going to put things somewhere, you don't know where, that means that all your .properties file or configuration, or whatever is the way that you're configuring your applications today, you know, that file where you put, this is the IP of my database, that cannot exist anymore, because you don't know where your database is. And the way how to discover it, I think it's coming next slide. So, we don't know where our things will run. What do we do? We do with service discovery, right? Do you know what Zookeeper is? etcd, console. It's hard for me to explain if you don't. Okay. So if you don't know where your services are, you cannot have static configuration. You cannot say what I said before, this is the IP of my database, because you don't know where it is. And if you fool yourself thinking that today is better because you know where it is, wait until that server crashes. So what we're using today is this service discovery, meaning that instead of all your configuration files, you have a place where you ask, where is this? And it will answer you. Those are all very scalable, very lightweight and fast types of databases where you store all the information. You always request something, information about something, instead of configuring it something. It consists always of 3 parts, meaning that you have registry, some place where you put something, you have a process that puts that something, and finally templating that will provide information for that. So, tools that you haven't heard, so I can say whatever I want, except that guy, he can shut his mouth. So Apache Zookeeper, written in Java, so that means very slow. Written a long time ago, don't use it. etcd, console, very cool. If you adopt Docker, then from a couple of months ago, you don't need any of those, because there is a 4th option that is baked already in the engine. And quite a lot of tools that I'm not going to go through, because this is very new. What is very important is to avoid coupling. Meaning that if you start exploring those things, you will probably reach the same fascination many others reached before with Netflix, right? If Netflix is doing it, that means it's good. It's not. And it's not because them and many other solutions require that you add something in your code. Never do that. Never accept a library that will provide service discovery or any other functionality that is not really directly related to your code, because then you have coupling and you cannot get out of it ever. So, we have the data stored in a service registry somewhere, and we don't want to couple our users with that. We don't want our users to request it from that registry every single time, so how do we make it accessible? How do we make it accessible is with a proxy, right? Now, this must be something that you use. Right, if you haven't, you know what proxies is. We have hardware proxy. Fortunately, nobody's using that anymore, right? Unless you have a very good deal with IBM that gives you a discount. So we have services, right? Apache, everybody using it. It's not proxy, please don't use it. Nginx, HAProxy really good. The problem with all those is that, again, they were designed around 10 years ago. And the problem with that is that they're very hard to modify. They're not dynamic at all. And if you're approaching that system where we're deploying multiple services every single day and updating and all those things, those tools need to be updated as well. So you need to have some kind of dynamic proxy. You can check this one or something else, as long as it's actually hooked into service registry. So you can reach through the proxy any service, wherever it is. How do we deploy it without downtime? Who goes to your office on Saturday to deploy? Because that's when you have least impact to your users. Huh? That's good. I thought somebody, at least there is always somebody. So you cannot really stop your application from running, right? Because that's a downtime. So the only options you have left then, I mean, some of the options is rolling updates, meaning that you're hopefully running at least 3 replicas of your services, and you would update one by one. And while doing that, change your proxy so that it points to both releases. They will be running during some time in parallel. Gather metrics from your users, and if everything works fine, continue with the next replica and all those things. Nothing really new. All blue-green deployment, which is cool if you're a small shop. If you're big, then you really need a lot of resources. You know what blue-green deployment is? No? Right. Okay. Blue-green, in a short version, is meaning that you have release 1 running, and then you put release 2 in parallel with release 1. Test. Once it's running, change the proxy to go to the next release. Remove the previous one, and go home. So, no downtime caused by deployment process, but there is still much more than deployment, right? Continuous integration. Are you using continuous integration? CI. Oh, finally. Continuous integration, right? It's one of those things that should never existed. The reason, because like kind of it was hijacked with companies saying that everybody's doing continuous integration, nobody's really doing, because it allows you to fake things. But anyway, automate integration flow. You merge to your main branch at least once a day. Are you merging those that you raised your hand? If you're not merging to main branch to master branch every single day, remove continuous from the word. You have integration. That's what you're left of. So because simply if you don't merge every single day, at least, you're postponing. It's not really happening in real time. Fixing failed flow has the highest priority, meaning that if something fails, you don't postpone fixing it. It needs to be done as soon as possible before you move to something else. The problem with continuous integration is that it really does not specify in any formal way where it ends, right? We know where it starts. It starts with a commit. With commit, we start the process. But where it ends, we don't know. Probably it ends somewhere, and then there are manual testing and manual deployments and all those things happening afterwards, right? That's why it's so appealing, because everybody can do it. Everybody can fake it. It's not a production-ready process. So continuous delivery, again, evolution of continuous integration. You need to be doing continuous integration, otherwise it's kind of silly to even try. Your software is deployable throughout the life cycle, meaning that every single commit that did not fail any of the automated tests, no manual anything, automated, can be deployed to production, right? So you can go to your cleaning lady, the lady that cleans your office, and say, press any of those buttons. It will go to production, nothing bad will happen. Then you're doing it right? Otherwise, you're actually taking it again. Prioritization of keeping software deployable, which is kind of obvious, and everybody gets fast feedback. Again, obvious. The only really manual process in all that is that button, say, deploy. And then, so that means that every commit can be deployed to production, and pressing to the button is what really does it. So, what do we need from tools to do all those things? And the reason why I'm coming to continuous deployment only now is because realistically, until you solve all the other problems that I spoke about before, and quite a few others, you cannot really reach this. So you need a way to define complex flows. Not too complex. If it's too complex, then really doing something terribly wrong. It needs to be defined as code. I think that later today you will have a session on Jenkins pipeline. You can see one of the ways how you can define those flows as code. Never accept click, click, click. Teams needs to be autonomous, meaning that if you have CI/CD department, same as the DevOps department, they're just terrible. You need to let your teams do their pipeline, decentralized. And finally, I work for Jenkins, so I need to say that Jenkins is the best tool ever. Now, once you figure all this out and start deploying continuously to production using those schedulers, service discovery, and all those things, you're still not nearly done, right? You need to figure out what to do with logs. Right? Logs cannot live in files, simply because when they're in files, they're in many, many, many servers. And when you have many replicas of many services deployed to many servers, then you will never find information, right? If you have a hobby site, 2 servers, that's okay. Anything bigger really is not. So we need to move logs into some kind of central database. So everything I did by now is about decentralization. This is the first subject where actually things must be centralized. Must be in a database, and it must be, when I say database, I don't mean Oracle. It needs to be something that is fast. And something that can be queried in real time. And something that can accept any type of data, because we don't know what our logs are. It can be really anything. So database, real time, and you need to be able to query all those things and find information that you're really needing. So what are we using today? I mean, this is now a bit harder one, because people usually go for ELK stack, Elasticsearch Log Stack Kibana, because it's free and popular. You have other services, just Google it. Google ELK versus, and then whatever Google gives you, it's a good alternative. Finally, metrics, right? Again, same like logging, you need to collect all those things, what is happening in your servers, if you're gonna ever reach that nirvana of self-healing, right? It's gonna recuperate for failures. It cannot do that if it doesn't have data. So you need data from hardware, you need data from software, and you need to do all of those things to gather all the data without modifying your services, because remember, your services are supposed to be specific to some business domain, not your metrics, logging, and all those things. You need to be able to query it, visualize it, and create alerts. Alerts are the key part, right? Usually things that people misunderstand. When I speak about alerts with people, they usually think alerts is something that is going to send me email when it fails, and then I'm going to ignore it. What really alerts are meant for is that they're going to notify some tool in your system that is going to respond to some metric threshold and do something, like increase number of replicas. That's alerting, right? And or deploy a new release, or add more servers to the cluster, right? And only if all those alerts and all those tools fail to do what it's tried to do, then you get email, not before that. So, any of you using Nagios? Do you know what Nagios is? It's Inga. Yes. Yeah, my condolences. Those are tools similar to CF Engine. They're simply meant to work with static clusters. They cannot cope with this. It's almost impossible to make them really work. Elastic Kibana, maybe, if you want something. If you're starting from scratch, you don't have anything, you can choose whatever you want. Then Prometheus is a really cool one. Among other things, because it's becoming standard, it's becoming it's part of Kubernetes. It's going to be part of Docker. It's part of. It's even going to be soon be part of quite a few cloud providers, and it really scales well. So, what else? I spoke about all those things. I mentioned only self-healing. I'm not going to go deep into it because I want to finish fast and let you ask me questions. That's more interesting than me speaking. Architecture needs to change drastically. That means that most likely, not necessarily always, but most likely, those big monolithic, huge applications, they will need to go away. You will need to take an X and start shipping it. Simply because you cannot scale monoliths. You can run them on multiple servers, but that's not really scaling. Culture needs to change, and so on and so forth. So, I spoke very fast because you're very unenthusiastic. This is my blog. Read it. That's my tweet handle. Tweet it. Those are my books. Buy them. And because you're so you have, I don't know, 15 minutes for questions. Me, English. Yes, please. Yes. How can they avoid? Oh, by changing almost everything. I mean, the biggest problem is usually, first of all, it's a culture. Meaning that you cannot go for continuous something if you're spread into silos. So like, do you have a testing department? You cannot have continuous. That's easy as that, right? Because it clashes, linguistically it clashes, right? Continuous does not mean throw over the wall to somebody else, open a Jira ticket and wait until that is done. That means the first step towards that is to take those testers and developers, put them in the same room, working on the same project, and having only one objective, that's to make that project work, right? You need to remove those departments. That's the first obstacle. That's a culture issue. And don't even try before that, the rest. Huh? No. First of all, I think that test coverage is useless. Test coverage, the only good thing about test coverage is to become a learning experience. So you don't know what testing is, excellent. We're going to hook you into a test coverage to help you out, learn how that works, right? But assuming that you adopted some form or another of test-driven development, meaning that you write tests in advance, that means that I wrote the test and I implemented exactly what the test tells me to implement. I don't need test coverage for that. Now, of course, if you have developers doing random stuff and then testers testing random stuff, you need a test coverage because nobody knows what the others are doing, right? But and you cannot. That's another thing. Like after that cultural stuff, if you want to go to continuous, you cannot not adopt continuous test-driven development. It's impossible. Simply because if tests are not done before the commit, then when commit before the change of the code, then when you commit that code and you start your CD pipeline, it will be green. It will work simply because there is no test to prove that it doesn't. So test needs to be done before, right? And that means test-driven development. Unit level, behavior-driven development, this or that, acceptance-driven development, I don't care. But tests first. No. No. As a department, no, they will stay. But same like other departments, like let's say infrastructure departments or other departments, they're supposed to help teams develop better. You cannot. That's one of the fallacies that almost every company, their testing department is called QA. Is your called QA as well? Quality assurance. It's not a quality assurance if you test it afterwards. That's quality checking. Quality assurance would be that you work with developers and say, I'm going to help you develop this product in a way that is better. It would be like QA is done in many cases, would be like, we're going to produce 1,000 cars and then check whether they work. I mean, you go bankrupt. But you should blame Henry Ford for introducing factory model and then we adopting it. Doesn't work. Somebody here raised the hand, yes.
Thank you. You mentioned like 5-6 services you have to run to actually be able to do this properly, right?
Yes. I mean, sometimes they're bundled or in the same package.
Yeah, but
sometimes,
still,
yes.
yeah. So I have application service, I have database service, or some kind of data service, and adding like 5-6 more. Do you think it's okay? Do you think in the future it should change into being easier and not learning 3, 4, 5 new services technologies just to achieve this?
Uh, easier does not necessarily mean no learning. I think that actually those tools that I showed, mentioned today and many others, actually make things much, much easier. I can guarantee that actually what I can do in an hour with those tools, without them it would take a day, guaranteed, probably a week, simply because it's like, let's say, deploy to 100 servers, 50 different replicas or something like that, right? It's really impossible. So, and learning many different tools, I have a bit different opinion about it than many others. I think it's for me it's easier to learn 5 different tools that are very specific, doing very specific thing, than one huge tool that does 90% of the things that I don't want, I don't need. To me personally, it's easier to. I prefer working with a few small tools that are very specific instead of one big ultra mega do it all and does nothing.
So follow-up question. Does this mean that you ideally will have a, you said the team should control more, be more involved into
Yes,
this,
definitely.
but the whole, this infrastructure part, should it also be done by the team or other department?
No, infrastructure, no, assuming that when you say team, you mean we have multiple teams in charge of multiple products, right? Something like that? Yeah. So, yeah, somebody needs to set up the infrastructure, meaning that, Kubernetes is used, I'm inventing now, Kubernetes is used by everybody, infrastructure department or whatever is going to set it up. But we're not going to deploy services to Kubernetes for you. You're in charge of that because you know what that service needs. I don't. So there is still a need for all those departments, but the roles are a bit different. I think that all horizontal departments, like infrastructure, should be in charge of setting up services that somebody else uses. And in my mind, Kubernetes being up and running is a service. Me deploying things to Kubernetes, that's a job of whomever wants to deploy something. I don't know if that answers your question.
It does, thanks.
Just a moment.
Regarding immutable deployments,
Yes.
so where do you draw line between immutable deployment and differences in configuration for connecting to different database servers for dev, for testing, for production, and how do you manage that line? What is production, SSL certificates, and test?
Production, for example, with service discovery, production is whatever service discovery, database is where service discovery tells me, right? I don't know where database is because I'm running a cluster, I'm not running 3 servers, right? And that should not differ from one environment to another, whether it's a testing cluster or it's a production cluster still. Database is somewhere that is a key called my database, right? What will service discovery respond? It's a different question. But so in other words, you don't change the configuration for the database in that example.
So basically, the configuration should be managed in this Zookeeper type or some better nowadays tool,
yeah.
and images itself just should query the.
Yes. For example, if you adopt software-defined networking, like for example, in case of Docker Swarm, let's say that you have 2 services, my service and my database, right? And they belong to the same network, software-defined network, right? That means in Docker terms, for example, that my service can access my database by calling my database because DNSs are updated on both services, right? So everybody can speak with everybody within the same network by using the name of the service. That's just one example. There are many other ways. So if I want to access my database, there will be a DNS entry in my database. What is the value? I don't care as application.
Okay, thanks.
Oh, this will be a tough one to pass. Run.
So if we use monitoring solutions for these deployments, from your point of view, which will be the key features from the monitoring software we use? You mentioned there is Nagios, Prometheus, or Zabbix. Like what?
Prometheus is good. First of all, you want your metrics to be to begin with. There are quite a few things. First of all, you need your metrics to be stored in a time series database because any other type of database is inefficient. That already excludes Nagios and all those things. If you don't like Prometheus, it can be quite InfluxDB, for example, is a good alternative, or let me think, probably a few others. Even Elasticsearch is better than those. Because first you need to think where you're going to store things. Then you need to think how you're going to get things, whether you're going to be pull or push model, long discussion which one is better. I prefer pull if I have software-defined networking. If I don't, then push is a better option. And then once you have metrics in the database, you need a powerful query language to query that. Again, that's where Nagios Isinga really fail, and those metrics need to be multidimensional, so they can be queried in many different ways, and so on and so forth. The only thing that you don't really need, and what everybody starts with, is a dashboard. It's kind of like, why do you want to look at the dashboard? I go to companies, they say, I need to show you a dashboard, and they have huge stream with the dashboard. So put Netflix. It's more interesting to watch Netflix than dashboard because you should have alerting that tells you when something goes wrong, not look at the screen like this. It's kind of pointless. I even forgot what was the question. Did I answer?
Yeah, it was about the key features of monitoring solution. So
yeah,
I
so
believe
multidimensional, it needs to be time series database. It needs to have labels to able to identify different features of some metric, and it needs to have a powerful query language and alerting system. Those are the key features. If it has it, it's good.
Thank you.
So just a moment. We have 5 minutes, and I think that we have a time just for 2 questions. Yeah.
There was a comment that killing the service and bringing up a new one is easier than
Server.
actually, well, server
Or service,
or
yes.
service. Doesn't matter. But don't you think that it heavily promotes bad coding behavior and attitude towards what you're developing, actually, and how to fight that?
Why would that be? Because if you made some terrible thing in your code, because you simply don't know what you're doing, that killing that service and rescheduling it somewhere else will not fix it.
Well, there are possible issues with connection management where killing the server, bringing up new will temporarily fix the issues, but if multiple fail at the same time, you might bring down the whole cluster. As an example, which hardly happens ever with single or dual core systems. Well, I had examples where this was an issue. So
how many servers you're talking about?
Well, currently 2, but
for 2 everything works. Everything works.
That's exactly my question.
Run it in your laptop. Yes.
That's exactly my question.
I mean, do one of those things. BlackBerry. No. Anyway.
What I'm saying, restarting this servers or recreating this service does not force you to actually investigate what is the issue.
No, quite contrary. Quite contrary. If I have immutable servers, meaning that if you want to fix something, you need to create a new image and then replace VM with the VM from the new image, then I know what I had and I know what I have now. I know what to fix. I'm not saying that simply, I was probably unclear. I was not saying, oh, something goes wrong. Kill the server and bring another one of the same thing that is going to go wrong again. I'm not saying that. I'm saying kill it and, fix it by creating a new, figuring out, you know what it is because you have an image, you have a specification of your server, create a new image, replace gradually one by one servers with a new image if something needs to be changed.
But with auto-healing systems, well, weeks can pass until you actually notice that because you will never be informed. Something failed, if we start. Well, surely if you're monitoring
you will
that
be informed, you have monitoring. And one thing is that when something fails, it will be restarted, of course. That does not mean that you should not know about it. All those tools, like for example, your service reaches a memory threshold that you set up like 2 gigabytes, and after 2 gigabytes it should die because obviously it has a memory leak or something like that, right? That you did not know about it. So quick fix is that scheduler, when you reach that limit, will kill it and bring a new one. But that's a quick fix. That's not fix of the problem, right? You need to find where that memory leak is and all those things. But most likely you're not going to reach that 2 2 gigabytes memory limit, simply because you have a metric system that is gonna send a notification to developer. Okay, this commit is obviously making increasing memory like crazy. You should do something about it. But for example, let's say one normal reason for something going wrong, which is quite common, is that let's say, oh, it's about to get new Christmas, right? Everybody wants to shop, and suddenly we have triple the traffic, right? So you need to do something about it, and you can do it manually, or you can have a system that actually increases the number of servers and services. And when that finishes, you should have that same system that is going to kill half of the replicas, because you obviously don't want to waste more resources than you need, because the increase in traffic fast. Does it?
More or less, yes.
I can do less or more.
So it's actually a follow-up question.
Sure.
These orchestration tools and the number of services that we actually need to succeed. So shouldn't these come together so that service discovery, kind of logging and metrics would be integrated? And I think this is happening with Kubernetes. No? You don't think so?
It depends what you mean integrated. It's one big black box, Kubernetes.
No, I'm not saying that, but I'm saying that, you know, like there is some service discovery with DNS inside Kubernetes.
Yes,
right?
Actually, if you're talking only about service discovery today, in my opinion, Swarm went further than anybody else, because it's actually part of Docker engine. It updates your DNSs all the time. You don't even know about the existence of service discovery. Now, whether that's a good or bad thing, that's a second. But it's kind of even more integrated than.
Yeah, but that's what I'm exactly saying. That's a good thing. I want that, and you know.
Then go for Swarm.
Yeah, I'm coming to your workshop, so I hope to see about that. But sort of Google is actually doing that with their Kubernetes offering in the cloud. So they have monitoring and logging kind of integrated, and I think that's an interesting option, don't you?
That's in general, it depends. And in this specific case, I think it's a terrible option.
Okay.
And the reason is that I think that there is nothing worse but by being locked by a hosting vendor.
Yes.
Because I mean, running all those things, Kubernetes and stuff like that, I think it's great. And most of those things you can get without being locked into GC. Now, I'm not saying anything against GC. GC, guys, it's great. But you don't want to be locked.
Exactly.
Because your options are then limited. So the same reason, for example, you can have, I'm going to say AWS simply because I'm more familiar, but you have CloudWatch that gives you logging and all those things, right? And it's not really, it's relatively easy to set it up without them, and then you're on your own. I think that you should be able to move from one provider to another effortlessly.
Yeah.
Relatively.
And you mentioned that Prometheus is kind of coming to Kubernetes somehow. I haven't followed.
Yeah, it is already in Kubernetes, and also since what was it, last summer? That was in Seattle. There was a presentation, DockerCon Prometheus, and community decided to integrate it into Docker itself. So basically, whatever runs Docker will get Prometheus formatted metrics. Now, whether you exploit those metrics with Prometheus itself or some other tool, it's up to you. But it will be part of the engine as well.
Very cool. Thank you.
You're welcome.
One more question, maybe?
Hey, so enough of tools.
Sure.
You made a very good comment about DevOps department.
There is no such thing as DevOps department.
Right, exactly. But when you have a developers team, it's not a team, it's a group of, let's say, 160 people working.
One team? It's not a team, that's a school reunion.
Not a team. So let's say 12 Scrum teams working on one product. You still may have microservices and everything, right? But somehow...
Again, 12 Scrum teams working on the same product, that's the same thing, just you call it differently.
Call it platform.
You changed the name.
Like. Call it platform.
Sorry.
Whatever. In Netflix, okay, if one day movie doesn't show up really, I will survive. If it's finances, if it's banking, I will be quite frustrated. But still, you need to have that governance at some level, somehow.
Okay.
So from your life practice, from your professional practice, for large-scale projects, platforms, whatever you call it, what to do with all this automation and everything, so you make sure that it is at least similar for each small project, each microservice, and so on.
Why do you want it to be similar?
For people to move around projects, for example.
But if people choose that they don't want similar, why would we insist on that?
You don't hire a separate guy for each different small component or bigger platform?
The problem with that, I want similar, which is a valid argument, I understand that. But the problem is that you're killing innovation. Because you say, okay, it's going to be this. Let's say that that's the best in the world, but nothing is best in the world for a long time. And once you actually put restrictions like it needs to be this and that, you're killing an innovation, effectively. Now, I'm not saying that you have to have innovation, but it must be a conscious decision. I don't want anybody to innovate. That's a valid decision, but must be a decision, right? And that's what you're getting with that. And I understand you, on the other hand, you cannot allow complete chaos. We're going to program in Perl. I mean, who wants to do that, right? They should be fired. Only in case of Perl. It needs to be balanced, of course, but it needs to be a high level of innovation, and if you want to advance, and that's only with freedom. So what I think are very good examples that I've seen, I cannot name companies though, but where companies set objectives and give tools, meaning that, look, your communication needs to be encrypted in this way. That's objective. And you might want to use one of the two solutions that we develop. But as long as you fulfill that objective, you're good to go. Because that's what we really need. It needs to be encrypted. How you do it, it's up to you. There is a department that is going to give you help if you want it. If you don't, doesn't matter. Or for example, Kubernetes. Say, okay, we have a department that actually is going to help you run your services in Kubernetes, right? And they know Kubernetes, they know Swarm. That does not mean that you cannot choose to run it somewhere else. It's your decision. As long as you fulfill objectives, you should be fine. I mean, that's at least how I like to, like in a bank, this needs to happen. It's not the same thing as do this, and that. Those are quite different things. But if you're talking about banks, we're talking about COBOL, so everything goes.
It's still our professional life.
I know,
right?
I know.
We still need to deal with it.
I work with
Thank
those
you for
customers
comment.
every day. So not every day. I would kill myself if it would do every day. But I work with them a lot. Yes. 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 Them a lot.